Hey everyone, welcome to ClassFly community. I am Darshini. In this video, we will learn few basic concepts of DFSM. DFSM is an abbreviation of Deterministic Finite State Machine. Firstly, let's see what is DFSM. A DFSM is a phi-tuple or quintuple. M equals Q summation delta Q naught A, where Q defines non-empty finite set of states, summation defines non-empty finite set of input alphabets, delta defines a transition function which is mapping from Q into summation to Q. Q naught defines start state, which is also indicated by lowercase letter s. A defines set of accepting or final state. Now, let us see an example. Draw a DFA to accept exactly 1A. Solution consists of transition diagram and transition table. Let us consider two states Q0 and Q1 represented by circles. This arrow indicates that Q0 is start state and there is transition of input A from Q0 to Q1 which satisfies our problem statement. Finally, two circles indicates final state where the transition ends. This gives the description of states and transition in the solution, where Q0 and Q1 are our states, A is our input, Q0 is our start state, Q1 is the final state, and the transition table consists of input A, Q0 is mapped to Q1 by input A, Q1 does not have any transition, hence it is empty. So this is an example of DFSM. Now let us know the types of representing DFSM. There are three types of representing DFSM: pattern recognition, divisible by k problem, modulo k counter problem. This helps us to rectify the type of problem of DFA. Now let us look at few simple and basic problems based on DFSM. Problem statement: obtain a DFA to accept strings of A's and B's starting with string A, B. Solution: where Q0, Q1, Q2 are our states. Q0 is the start state. So A, B are being mapped from Q0 to Q1 and Q1 to Q2 respectively. Now A has been already mapped from Q0 to Q1. Now to map B, we need a trap state Q3. Let us learn what is trap state later. Now B is being mapped from Q0 to Q3 and Q1 to Q3 there is A. B is already mapped from Q1 to Q2. Now Q3 has a self loop of A and B for itself. Now Q2 acts as a final state which has A and B as a self loop. Now Q0, Q1, Q2, Q3 are the states. A and B are the inputs. Q0 is the initial state. Q2 is the final state. Transition diagram consists of input A and B, Q0, Q1, Q2, Q3. Q0 is mapped to Q1 by input A, Q0 is mapped to Q3 by input B. Q1 is mapped to Q3 by input A and to Q2 by input B. Q2 is having a self loop of both A and B. Q3 is also having a self loop of both A and B. Now, what is trap state? A state for which there exists transitions to itself for all the input symbols chosen from summation and there is no way to reach the final state. That is trap state. In this problem, our trap state is Q3, which does not have any final state. Trap state is also known as dead state. So here is our solution for the problem. Now let us go to our next problem, which states that draw a DFA to accept strings of A's where number of A's is multiple of 5. So Q0, Q1, Q2, Q3, Q4 are the states. So as the problem states, there should be A's of multiple of 5. So here is the transitions respectively with the respective states. Now Q0 acts as both start state and final state in this problem. So Q0, Q1, Q2, Q3, Q4 are the states. A is the only input. Q0 is both the start state and the final state. Now let us see the transition of input A. Q0 is transmitted to Q1 by A, Q1 is mapped to Q2 by A, Q2 is mapped to Q3 by A, Q3 is mapped to Q4 by A, Q4 is mapped to Q0 by A. So as the problem states, 1, 2, 3, 4 and 5. So here it stops. It starts here and stops here. So satisfying the problem statement. This is our solution for the problem. Now coming to the next problem, draw a DFA to accept strings of A's where number of A's is not multiple of 5. Q0, Q1, Q2, Q3, Q4 are the states where Q0 acts as start state. Now the transitions of A from Q0, Q1, Q2, Q3, Q4 respectively. So now final states. Q1, Q2, Q3, Q4 are our final states. So will this satisfy our problem? Let us see that. So what our problem says is A, number of A is not multiple of 5. So 1A is being transmitted from Q0 to Q1 and it is being ended over there. So only 1A is being transmitted. And again your 1A is being transmitted. Here again 1A, 1A and 1A and ends. So hence it satisfies the given problem that the number of A is not multiple of 5. That is 5, 10, 15 and so on. Now Q0, Q1, Q2, Q3, Q4 are the states. A is the input and Q0 is the start state. Q1, Q2, Q3, Q4 are the final states. Now coming to this transition table consists of input A, Q0 is mapped to Q1, Q1 is mapped to Q2, Q2 is mapped to Q3, Q3 is mapped to Q4, Q4 is mapped back to Q0 by input A. Now comes the problem. L is equals to W where length of W mod 3 is equals to 0 where W belongs to A bar star. A bar star indicates infinite number of A's. Any number of A's can be used. So now coming to the solution part, it consists of Q0, Q1, Q2, Q0 is the start state. So A and another A and A. Q0 is our final state as well. So satisfying the problem statement, the solution has 1, 2 and 3 where it stops. And again 1, 2, 3. So mod 3 is equals to 0. The number of A's mod 3 is equals to 0. So this satisfies the given problem statement. Now, Q0, Q1, Q2 are the states. A is the only input. Q0 is the start state and final state as well. Now, transition table consists of input A. Q0 is mapped to Q1. Q1 is mapped to Q2. Q2 is mapped back to Q0. So that was the solution for the problem. And the next problem, draw DFA to accept strings of A's and B's ending with AAB. Q0, Q1, Q2, Q3. So these are the states. Q1 is the start state. A, A, B, which satisfies the given problem statement. So already A has been mapped from Q0 to A. So Q3 is our final state. So B has been self-looped on Q0 itself, not disturbing the given statement. So AAB is maintained as a ending string. Now A is already mapped to Q1, but B is not mapped. So Q1 is mapped to Q0 back to B. So Q2 is already having a transition of B from Q2 to Q3. A is self looped. Then Q3 finally is sending back A and B. It satisfies the given condition of the problem that B. A, A, B remains at the end of the string. So Q0, Q1, Q2, Q3 are the states, A and B are the inputs. Q0 is the start state, Q3 is the final state. Coming to the transition state table, A and B are the inputs. Q0 is mapped to Q1 by A. Q0 is having a self loop by B. Q1 is mapped to Q2 by A. Q1 is mapped to Q0 by B. Q2 is having self loop of A and Q2 is mapped to Q3 by B. Q3 is mapped to Q2 by A. Q3 is mapped to Q1 by B. That was other solution. Next problem, draw a DFA to accept strings of A's and B's having substring BAB. So Q0, Q1, Q2, Q3 are the states where Q3 is the final state and Q0 is a start state. So here is the transition of given string BAB. So B has been already transmitted from Q0 to Q1. Now A is being mapped to Q0 by a self loop on itself. Now A is already being mapped from Q1. So B is again self looped on Q1. So satisfying the given problem statement. Now Q2 B is already transmitted but A is not. So we can't take self loop of A on Q2 because it doesn't satisfy the given condition that BAB should be a substring. So A is sent back to Q0. So then finally Q3 is having a self loop consisting of input A and B. So this satisfies the given condition BAB. BAB substring is being maintained over all the solution. Now Q0, Q1, Q2, Q3 are the states. A and B is the input. Q0 is the start state. Q3 is the final state. Now transitions table. A and B are the inputs. Q0 is mapped to Q0 by itself, that is self loop on A. Q0 is mapped to Q1 by B. Q1 is mapped to Q2 by A, and Q1 is having a self loop of B on itself. Q2 is mapped to Q0 by A. Q2 is mapped to Q3 by B. Q3 is mapped to itself by both A and B. So this is our solution for the problem and it satisfies the condition. Finally, thanks for watching the video.